Okay, so we're going to do another example of a confidence interval, just going through the whole process, and then also talking about a little bit more about what confidence intervals actually mean and how we interpret them. So, in this one, an insurance company checks police records on 582 accidents and notes that teenagers were at the wheel in 91 of them, and we're calculating a 95% confidence interval for the proportion of all accidents that involve teenage drivers. So our first step is always to identify the parameter that we are looking for. What is it that we're going to estimate at the end of the problem? So that would be P equals. P is the symbol we use for a parameter, for a proportion, which is what we're trying to estimate here. And I'm just going to say something like the true proportion of all accidents that involve teenage drivers. So that is our first step. The second step is we're going to check conditions. So there are 3 conditions that we need to check. The first one is, do we have a random or assumed representative sample? In this case, it does say that they selected 582 accidents at random, so I'm going to say that we were given a random sample. Our next condition is the 10% rule, and this checks for independence between trials. So we want to assume that 582 accidents is less than 10% of all accidents, which definitely seems reasonable. And then our last condition is the one that checks for normality, or if a normal model is able to be used. And for that, we check does n times p, or n times p hat technically, and n times q hat, or 1 minus p hat, do both of those come out to less than or equal, greater than or equal to 10, sorry. So, with this one, our n is 582, and then our p, or p hat, is 91 out of 582. That's the proportion that teenagers were at the wheel. So when I think about just basic math, 582 times 91 out of 582 is just going to end up being 91. So that is why we sometimes call this the success-failure condition, is because we're basically measuring does the number of successes, in this case, our success is defined as an accident with a teen driver, since that's what we're measuring, and then the number of failures, which would basically be the rest of the accidents that did not involve teen drivers, which, if we do a quick subtraction, is 491, right? And both of those are greater than or equal to 10, which means that a normal model is okay to be used on this problem. Check. Sometimes I'll put normal model smiley face, something like that. So that is our second step. The third step is to actually calculate the interval. So for that, our formula is p hat, our sample proportion, our point estimate, plus minus our critical value z star, times square root of p, or technically p hat, because that's all we know, times 1 minus p hat over n. That square root is basically our standard deviation. So if I go ahead and plug in values, right, we have 91 out of 582. That is our sample proportion. Now I could go ahead and find a decimal for that, but I'm going to leave it as the fraction for now so that I'm not rounding. I'll do plus minus. My confidence interval or level is 95%, so my z star for that is 1.96. And then times the square root of p, or p hat, so 91 out of 582, times 1 minus that, 1 minus 91 out of 582, divided by 582. So notice I just kept the p hat as a fraction for everything, just to make it less roundy. Now when I actually figure this out in my calculator, there are several different ways that you can get around the whole fraction-y thing. Again, if you divide 91 by 582, we get a decimal that's kind of long. So you could use a somewhat rounded version of that. It's 0.1563557, etc. So you could kind of use maybe a rounded version of that, 0.1564 perhaps, would probably get you pretty close to the correct interval. But another way that we can deal with that is by using the store function in your calculator to store our p hat, our 91 out of 582, as a full answer, and that way we're not rounding mid-step. So I can see that I did that 91 out of 582 right here, and then I stored that. The store button is right here next to the 1. I pushed that, and then I did alpha, and then I did P for P hat. You can use whatever letter you want. And then when I go and do my actual formula, right, I'm able to just use P and not have to worry about typing in that decimal a million times. And that way I get a very, very exact answer without having to type a whole bunch of extra complicated formula stuff. So the interval that I get is the lower end is 0.127, we'll say, and then the upper end is 0.186. So that is our answer, right? So now the last step, that was the third step, is to actually calculate the interval. And then our last step is to actually interpret the interval. So when we interpret the interval, we're explaining what those two numbers tell us in the context of what we were asked to find out. We were asked to calculate the interval to estimate the proportion of all accidents that involve teens. And now we have an estimate for that, and we want to make sure and explain it. So there are three components of that interval, or that interpretation, that we want to make sure and include. The first one is the confidence level, which is saying that you are 95% confident, or however confident you are. We never know anything for sure in statistics. We're always just really, really confident based on numbers. So we are 95% confident. The next thing we want to make sure and include is context. So making sure to talk about accidents and the proportion of accidents involving teens is what we are actually estimating here. So we're 95% confident that the true proportion of all accidents involving teens. And then the last step is, of course, to include the interval itself. We're not just saying one single number. It's not for sure going to be exactly 91 out of 582. We want to make sure that it's somewhere to say that it's between those two numbers. And there we go, we have an interpretation. So in terms of interpretation, remember that there are two things that we could be asked to interpret. So we're done with this problem, but I want to talk a little bit more about interpretations. So there's two different things we could be asked to interpret. The interval itself is something you should always do. When you calculate an interval, you should absolutely always interpret that interval. Right? That's where we say we're 95% confident that the true proportion of all accidents is between these two numbers. So we're always, always, always interpreting the interval. But sometimes we will be asked to interpret or explain the confidence level. So the confidence level is explaining what does it mean to be 95% confident. Right? So that is where we would say the thing about using the method for many samples. If I were to repeat this many times, about 95% of the intervals we calculate would include that true proportion of accidents that involve teens. So just to demonstrate again what we mean by that, right, here are a bunch of intervals. This is the one that we actually just calculated based on that 91 out of 582. But if I were to repeat that sampling process, if I were to continue to take random samples of 582 accidents and find what proportion of them involve teens and calculate intervals based on those proportions, these are a bunch of other intervals that I could possibly get. So not every interval is going to be the same, not every sample proportion is going to be the same. We're going to have some differences. But the idea is that most of them, about 95% of them, should include the true proportion. Now, unlike the example we had with the coins and the coin flipping, where we knew what the true proportion was supposed to be, was 0.5, so we could visually see like, oh yeah, almost all of them included 0.5. In this example, we don't actually know the true proportion. We just know that at least 95% or around 95% of these intervals that we have should include that true proportion. All right, so that is kind of the explanation of the confidence level. It's explaining what it means. It's kind of like a success rate. How likely are we to be successful in including that true proportion using this method? Okay, so I'm going to look at a little bit more things now in terms of what the intervals actually mean and things to be careful of. So in this example, it says Pete's running for class president, decides to poll some students. He samples 100 students and calculates a 95% confidence interval for the proportion of students who will vote for him, and he calculates the interval 0.45 to 0.52. So what does the interval mean? Well, it means that he is 95% confident that the true proportion of students who will vote for him is somewhere between 0.45 and 0.52. So does Pete know that he's absolutely going to win the election? And the answer is no, he doesn't know that for sure. Because that true proportion, even with his 95% confidence interval, that true proportion could be anywhere between those two numbers. So it could be 0.46, it could be 0.465, it could be 0.51, it could be 0.5115, it could be anywhere in between those two numbers. There's no part of the interval that is more or less likely than any other part of the interval. We're 95% confident that somewhere between 45 and 52% of the students will vote for him. So no, he's not sure that he's going to win the election. This sample, or this thing, didn't help him. Part B says, how would raising the confidence level to 98% change the interval? Okay, if you remember from the last lesson, I talked a little bit about this, but the bigger the confidence level, the wider the interval, because the bigger the confidence level, the bigger the Z star. The wider or the more of the normal model that we're taking in. You can kind of picture it as we're always putting P hat at the center of our imaginary normal model that we're not necessarily drawing, but it's going on in the background. And that percentage is basically saying how much of this normal model am I going to include in my interval. So if I'm going to include more of it, then that interval has to be a little bit wider. So it's going to make it wider, which basically means it's not going to really help him, because then it'll be like 0.42 to 0.55. I don't know. I'm making that up. I don't know what it'll actually be. But if it's even wider, then he's still not sure whether or not he's going to win. So being 98% confident wouldn't necessarily help. He could lower his confidence level and maybe be a little bit more sure. But, yeah. And by more sure, I mean his interval might be completely under 0.5 at that point, but he would still be less confident. And then part C, Pete wants to take another poll, but due to time constraints, he only has time to sample 40 students. How would that change his interval? 40 students, a smaller sample size, is going to also potentially make his interval wider. Remember that when we talk about our margin of error, what we're adding and subtracting, n is in the bottom of a fraction, which means the bigger it gets, the smaller your margin of error or standard deviation gets. And the smaller that value of n is, the wider or bigger your margin of error is. So this change in sample size, a smaller sample size, would also make the interval wider than it was originally, because it now has a bigger standard deviation, which is going to make the interval wider. So really out of luck here, unless he takes a bigger sample, we won't necessarily know, or if he's less confident, he won't necessarily know for sure whether he's going to win or lose. Alright, there's going to be 2 more questions I put on here just to practice. I've mentioned this a couple times in class, but a lot of times in terms of multiple choice questions on AP exam, they give you an interval or they give you a situation and ask you just to choose which answer is correct. And sometimes they'll say like which one correctly interprets the interval, or which one correctly interprets the confidence level. But sometimes they'll just say something like this, where it's like, which one is correct, right? Now this one technically is asking for the correct interpretation of the interval. So really, we should be looking at answer choices that include or talk about the interval. So going through the answer choices, the first one says we're 95% confident, so we included the confidence level, which we always should, that the true proportion of voters in favor of Pete, that's correct. It included context, and it also made sure to mention that we're talking about the true proportion, the parameter, not just the statistic, and then is between 45 and 52%. So they included the interval. So that one actually looks pretty good, but just to go through some of the rest of them and why they're wrong. We should never ever be saying that there's a 95% or whatever confidence level probability. It is not truly a probability, and to say it's a probability is missing the point of a confidence level. So that is one thing to be on the lookout. If you have multiple choice questions like this, if there's any of them that mention it as a probability, it's very, very likely not to be the right answer. Part C says if we were to repeat this procedure many times, 95% of the sample proportions would be between 45 and 52. So a few things here. If this procedure were repeated many times, seems to be going for an interpretation of the confidence level, explaining what the confidence level means. The problem is that they mention sample proportions, which are interval. Any of these interpretations should always be talking about the population. And then it mentions a specific interval. When we're trying to interpret the level, we shouldn't mention a specific interval. We should always mention just a more generic interpretation. Part D, or answer choice D, says the true proportion of all voters is definitely between, so they didn't include the confidence level. Not definitely anything. Answer choice E, if this procedure were repeated many times, approximately 95% of the resulting intervals would capture the true population proportion. This isn't a correct interpretation of the confidence level. So this is correct. It is not technically an interpretation of the interval, so if this were, we would choose A and not E. But this is also correct for the confidence level. And then F says we're 95% confident that the sample proportion of voters is in between the interval. So that's another thing to be on the lookout for. Our interpretations is always about the true proportion. That's what we're actually trying to estimate. We know what the sample proportion is. We don't have to have an interval for the sample proportion. All right, so again, A and E are both correct statements. A is the one that correctly interprets the interval. E interprets the level. So then another one, right? They found 44% in favor of stricter gun control laws. The margin of error, they say, is plus minus 4%. And they want to know, are these statements about the laws true? So again, this one, really, they're just saying which ones are true. We could be looking for a correct interval interpretation, or we could be looking for a correct level interpretation. So we just have to read carefully, look through our answer choices, and see any kind of major things that are not supposed to be included. So for example, this one says in the sample of U.S. adults, somewhere between 40 and 48% were in favor. In the sample, exactly 44% were in favor. So that's not right. If they had said in the population, then we may have been on the right track there. B says we're 95% confident, but then it doesn't mention an interval. It just mentions the one number. So that's not right. Right. C says we're 95% confident that between 40 and 48, so far so good, of all U.S. adults, we're talking about the population, good, are in favor of stricter gun laws. We included context, so C looks happy. D says we know, we never know anything, absolutely not. That's already a magic X out. And then E says 95% of all U.S. adults, really hugely misinterpreting what the 95% tells us, right? And plus it doesn't even make sense because they told us that the sample is 44 and our margin of error is 4%. How would it be 95% in favor? That's silly. So absolutely not even close. So that is a few examples of some multiple choice questions you might get related to confidence intervals. And now I'm done blabbing at you.